Hello wonderful person, this is Anton, and today we're going to be talking about a mystery coming from a planet here in the solar system. And this planet right here, Uranus. Now, today we're going to be talking about the rings of Uranus. So if you didn't know that there were rings of Uranus, so let's start with that. First of all, you can actually see them pretty easily right there. This is in Space Engine. But the thing about rings in our solar system is that every major gas giant and ice giant has rings. Now, let's start with the obvious one, Saturn. The object about whose rings I actually talked about recently, where we were able to solve the mystery of the so-called Cassini division, which is the gap between the rings you see. This is basically the most famous ring planet in our solar system. However, Jupiter also has rings. Specifically, it has 4 rings. Here's a illustration showing you where those rings are located, and even though they're kind of difficult to see, they're definitely there. They are mostly made up of really small dust, and we believe that they were formed by probably an asteroid or something coming really close to Jupiter and then falling apart due to the tidal forces. Then we have the farthest planet, Neptune, and it has 5 rings that are very similar to the rings of Jupiter in terms of the size and the composition. I'm actually very close to one right now. But they're also not very large. They're relatively small in size compared to, I guess, Saturn. And so you can kind of maybe see them right there. These rings are very difficult to see as well, but they are also there and probably formed in a similar way to how Jupiter's rings formed. But then we have Uranus, a very unusual planet that also seems to have the strangest rings in the solar system, at least as of today. There are 13 rings around Uranus, and we've only discovered them in 1977 with the Voyager probes, but for the most part, we don't really know much about them because they're really difficult to see. They're actually really strange because they don't reflect a lot of visual light and can only really be easily seen in the infrared. Unfortunately, visually, we don't really know very well what they look like. And so for the first time ever, the researchers whose paper you can find in the description below were able to take a thermal image and actually measure the temperature of the rings while also being able to visualize them, as you can see on the screen. And what they discovered is a little bit unusual. So first of all, the main ring of Uranus is known as the Epsilon ring. Here's a slightly better way of seeing it. This is the largest ring of Uranus. There's obviously other rings, but this one is the biggest. And surprisingly, it's like nothing we have in the solar system. It is extremely strange. One of the biggest, strangest things about it is that it doesn't have any small dust particles. Everything here seems to be really large chunks, bigger than a golf ball. And it also, like I said, is hard to see, and we don't really understand how it was created or what it's made out of. Because the second strange thing about the Epsilon ring, or really all of the rings here, is that they are approximately 30 degrees warmer than the planet Uranus itself. Now, it doesn't mean that they're hot. They're still pretty cold, actually. They're roughly around 77 degrees Kelvin, which I believe the scientists compared to the boiling point of liquid nitrogen. But the surface of Uranus is even colder. It's approximately 47 degrees Kelvin, because this is actually the coldest planet in the solar system. Now, in one of the previous videos from a few years ago, I explained a study where they tried to determine why it's so cold, and the conclusion was kind of related to why the planet is also so tilted. As you may know, Uranus has a very unusual axial tilt of roughly around 98 degrees, and the explanation for this is that it received a collision that made it go sideways, while at the same time losing a lot of internal heat and very likely causing the object to also produce some of its moons and maybe even the rings. That's potentially one of the explanations for why the rings are so unusual. So the temperature here is actually pretty low. It's, like I said, the coldest object, but the rings are surprisingly warmer. And considering the fact that it's really far away from the sun, it's difficult to explain why they are so warm. At the same time, it's very difficult to explain why these rings are so different from other rings in the solar system. As I mentioned before, both Jupiter and Neptune have very fine dust rings. They're, for the most part, really dark, containing a lot of dust particles similar to the particles you find in the asteroid belt or in the Kuiper's belt. The rings of Saturn are very diverse, they're very different, there's a lot of stuff going on there because they're formed in different ways, but these rings seem to only contain large golf ball-like objects and are surprisingly warmer than the actual planet. So there's a lot of mystery behind these rings and there's no good explanation for it. But just to clarify this, there's still some dust here, specifically in between the rings. You can find quite a lot of various dust particles. But the rings themselves, if you were to go inside of them, would contain only large objects. There would not be a lot of dust here. They're also surprisingly narrow compared to other rings and seem to be concentrated in these 13 really narrow formations. So, like I said, more mysteries than actual answers. Now, in terms of how these were created, we still believe that they probably were either formed by an object that approached Uranus really close and fell apart, or possibly were emitted by one of the moons of Uranus, and we can actually take a look at some of the moons here that are orbiting around Uranus, with one of the more famous moons being this one, Ariel. So it's possible that maybe some sort of a geyser emission or just a collision with an asteroid caused these rings to be formed and produce the formations that we see today. Or the last explanation for the existence of these rings is, as I mentioned, from the collision Uranus may have received. There are actually several papers out there, some of them I've previously mentioned on the channel, that try to simulate the collision that Uranus may have received that resulted in its unusual axial tilt that could also have produced these rings. As you can see, there are some particles here that could potentially create the ring formation. So if that's the case, if this is how these rings were produced, this would be really important for us to study because it would allow us to analyze the actual particles that may have been coming from inside Uranus or inside of this other object that it collided with, while also kind of learning more about the creation of the solar system. We don't really know when this collision happened, but if it was a recent collision, maybe we'll even be able to discover what happened to this object, because we're not really sure right now. Today, the best explanation for the weirdness of Uranus is actually this collision, so planetary collisions is definitely something that we're interested in studying more. And because today this is essentially the best explanation for why Uranus is so weird, it's something that we need to kind of study. So I guess what I'm saying here is that we need to send a mission here and we need to try to find a way to bring a probe that will be able to analyze all of these rings, study their composition, possibly study their origin, and also discover what exactly happened to Uranus several million or billion years ago. Now, all in all, this is definitely one of the weirdest planets, but it just got officially weirder. It seems to have received a new status of having the strangest rings in the solar system. Anyway, until we discover more, that's all I wanted to mention in this video. And so if you've enjoyed this video, don't forget to subscribe, share this video with someone who loves learning about space and sciences, and come back tomorrow to learn something else. I'll see you tomorrow, space out, and as always, bye bye.